Hey, hi everyone, welcome back to this video series on Windows Server 2016. Windows Server containers versus Hyper-V containers. When Microsoft had people start testing and using containers, what they found is that many places were developing only one container per VM. Well, that's a little silly. Sure, they are getting the DevOps benefit out of using the container approach, but you aren't getting any benefits out of the resource of sharing a small footprint of a data center. After doing a little digging, they discovered that companies were doing this because containers natively share kernel. While this is imperative to the performance of the containers, this is a problem for isolation, and organizations were reluctant to deploy containers within a single VM. So Microsoft created a compromise. When spinning up your containers, it is important to know that there are now two categories of containers that you can run in Windows Server 2016. All aspects of application containers that we have been talking about so far apply to either Windows Server containers or to Hyper-V containers. Like Windows Server containers, Hyper-V containers can run the same code or images inside of them while keeping their strong isolation guarantees to make sure the important stuff stays separated. The decision between using Windows Server containers or Hyper-V containers will likely boil down to what level of security your containers need to maintain. Let's discuss the difference between the two so that you can better understand the choice you are facing. It is important to point out that the developers who are building applications inside your containers don't need to know or care about what kind of container the app is going to reside in. This is purely an IT decision and has no bearing on how the application behaves within the container or how it needs to be built. Windows Server containers, in the same way that Linux containers share the host operating system kernel files, Windows Server containers make use of this sharing in order to make the containers efficient. What this means, however, is that while namespace, file system, and network isolation is in place to keep the containers separate from each other, there is some potential for vulnerability between the different containers running on a server. For example, if you were to log into the host operating system on your container server, you will be able to see the running process of the container itself. The container is not able to see the host or other containers and is still isolated from the host itself in various ways, but knowing that the host is able to view the process within the container shows us that some interaction does exist with this level of sharing. Windows Server containers are going to be the most useful in circumstances where your container host server and container and the containers themselves are within the same trust boundary. In most cases, this means that Windows Server containers are going to be the most useful for servers which are company owned and only run containers that are owned and trusted by the company. If you trust both your server and your containers and are okay with those entities trusting each other, then deploying regular Windows Server containers is the most efficient use of your hardware resources. Hyper-V containers. If you're looking for an increased amount of isolation and stronger boundaries, that is where you will foray into Hyper-V containers. Hyper-V containers are more like a super omnitized version of a virtual machine, while kernel resources are still shared by Hyper-V containers so that they are still much more performant than full virtual machines. Each Hyper-V container gets its own dedicated Windows shell within a single container can run. This means you have isolation between Hyper-V containers that is more on par with isolation between VMs, and yet are still able to spin up new containers at will and very quickly. because the container infrastructure is still in place underneath. Hyper-V containers are going to be more useful in multi-tenant infrastructure where you want to make sure no code or activity is able to be leaked between the container and the host, or between two different containers that might be owned by different entities. A minute ago, we discussed how the host operating system can see into the process running within a Windows Server container, but this is not the case with Hyper-V containers. The host operating system is completely unaware of and unable to tap into those services that are running within Hyper-V containers themselves. These processes are now invisible. It's important to know that you can change regular Windows Server containers to be Hyper-V containers with a simple PowerShell command. This way, if you are running a container and later realize that you created it incorrectly, or simply decide that the other mode is better for your application's use, you simply stop the container and use PowerShell to convert it. In the very next section of this chapter, we will be using PowerShell in order to start up a new container, and we will take a look at the set container cmd-let to swing this container back and forth between a Windows Server container and a Hyper-V container. The availability of Hyper-V containers means that even if you have an application that must be strongly isolated, you no longer need a dedicated or full Hyper-V VM to this application. You can now spin up a Hyper-V container, run the application in that container, and have full isolation for the application, while at the same time continuing to share resources and provide a better, more scalable experience for that application. Starting a container with PowerShell. Any of you who have worked with containers already know that this section heading is misleading. I did that on purpose so that you will soon see we can utilize PowerShell as our command line console to do that work, but we aren't actually using PowerShell under the hood at all in order to accomplish our work with containers today. Let's take a look together and find out how easily it is really to start using containers inside Windows Server 2016. The first thing you need is, of course, your server. I have a fresh Windows Server 2016 running. There are a couple of things we need to accomplish on this server in order to prepare it for running containers. I would like to note here that the process is still evolving and may continue evolving. The infancy of Windows Server 2016. As of this writing, there is a quick process that we're going to use, which makes the process of getting familiar with the commands and spinning up your first container pretty easy, but even this process may change in the future. Preparing your container host server. To start using containers on your server, there is a simple feature that needs to be installed called containers. Installing that feature installs the PowerShell cmd-lets and functions needed in order to start and manage containers on your server. In addition to that, if you intend to utilize Hyper-V containers, then you also need to make sure that the Hyper-V role has been installed on your container host server. In taking this straightforward role installation approach, however, you will end up with no real way to start a container because you won't have any base images from which you can start new containers. In order to make our server more robust and ready to actually start an image, we are also going to install something called Docker. If you aren't familiar with Docker, there's a section coming up later in this chapter that gives you a little detail on Docker itself. But for the purpose of spinning up your first container, you simply need to follow the directions which will install it for you. Before we get started, I want to take a minute and chase down our rabbit trail. At this point, you may be wondering if my container host server needs to have the Hyper-V role installed. Doesn't that mean it must be a physical server? You can't install Hyper-V role onto a virtual machine, right? Wrong. Windows Server 2016 supports something called nested virtualization, which was added really for the purpose of containers. You see, requiring physical hardware is becoming a limiting factor for IT departments these days, as almost everything is done from virtual machines. It makes sense that companies would want to deploy containers, but that they would want their container servers to be VMs with multiple containers being run within that VM. Therefore, nested virtualization was required to make this possible. If you are running a Windows Server 2016 physical hypervisor server and Windows Server 2016 virtual machine inside that server, you will now find out that you are able to successfully install the Hyper-V role right onto that VM. I told you virtual machines were popular so much that they are now being used to run other virtual machines. To maintain, the main resource for Microsoft documentation on containers is https aka .ms Windows containers. Make sure to check over the site in order to find the latest best practices and approved installation path for preparing your container host servers. I have already installed Hyper-V role onto my new server. Now I'm going to install the containers feature by using the following PowerShell cmd let. Install Windows features. After the installation of our new containers feature, make sure to reboot your server now that containers is ready to go within Windows, giving us the core under the hood functionality. We need a special tool set called Docker to interact with these containers. The Docker files can be downloaded here. https download.docker.com components engine Windows Server CS 1.12 docker.zip. Now it is important to note that this is not an actual installer that you have to run. Instead, unzip these files and place them somewhere on your system, such as C, Programs, Files, Docker. Next, we have 3 commands to run within PowerShell. These commands will add this new Docker directory to our system path so that we can run commands within from any PowerShell prompt, and then our next commands will install Docker as a service and start that service. To set the path environment, set environment variable path $env path plus C : program files Docker environment variable target : machine to install the Docker service docker.exe registry service to start the new service, start service Docker. Starting a Windows server container. Now that our new Windows Server 2016 has been prepped to be able to run the containers, let's jump right in and start one up. We'll be doing this work from a PowerShell prompt. Before we start a container, we need to decide which base image we are going to use in order to build this container. You can use the command docker images in order to see currently available images on our system. Well, that looks like a whole lot of nothing. We don't have any container-based images on our system by default, so it looks like we need to reach out and get one by using the integration with Docker that we have already installed. We have simple, easy to use commands that we can use to pull down sample base images from a repository that we will talk about at the end of this chapter called Docker Hub. Microsoft has a repository on Docker Hub that allows us to pull down pre-created images that we can start up new containers. As an example, I'm going to run the following command that will pull down a container image that is based on server core and will have the IIS role installed. Docker run 8p80:80 Microsoft IIS cmd. Since I did not have this image on my system previously, it needs to take a few minutes and download it from the repository. Once complete, the container is automatically started and IIS is up and running on this container. My server is not very powerful, and yet the process of starting up the container only took a few seconds to finish. That was a whole lot faster than spinning up a new virtual machine inside Hyper-V Manager. Another way to get base images onto your server 2016 without starting up containers automatically is to issue a Docker pull command, which tells the machine to pull down Microsoft's base image of either server core or nano server. Here are the commands: Docker pull Microsoft / Windows Server Core, Docker pull Microsoft / nano server. After downloading those base images, you can use commands like the following to spin up new Windows Server container instances: Docker run it Windows Server Core CMD, or if you want to start Hyper-V container, you can simply add one flag to the command Docker run it isolation equals hyperserv nano server CMD. I have run some of these commands on my system, downloading the server core IIS and the nano server base images. And now if I rerun Docker images, I can see those base images on my system. You may be wondering, why do we need to use the Docker command to do everything? Where are the PowerShell CMDlets? This is a particularly confusing question at the moment, because in earlier technical preview versions of Server 2016, there were PowerShell CMDlets available from which you could create containers, start containers, and interact with containers. But at some point in the process, Microsoft made the decision to revisit this platform. And at the present time, I'm not able to find good information about whether or not PowerShell is going to be interfacing with containers in the future or not. All of the current documentation points to using Docker directly. So we are making assumption at this point that the Docker controls will be your primary and possibly only way to interact with your containers. What is Docker? You're probably wondering why we waited to talk about Docker until now, when we have already installed it and have been using the commands in order to interact with containers. The reason I chose to jump right into using it first and explaining it later is that many IT folks who have started reading something about a toolset called Docker that is open source, works on Linux, and so on would instantly glaze over and skip this section anyway. I know I would have, since you can now clearly see that Docker is a control mechanism that we will still need to get familiar with if we plan to work with containers. Hopefully your interest is now piqued rather than being dissolved. So let's just have a few words on what Docker actually is. Docker is an open source project, a tool set really, that was originally designed to assist with running the running of containers on Linux operating systems. Wait a minute, what? The words Linux and open source in a Microsoft book. What in the world is going on? You see, Microsoft thinks that containers are going to be a big deal, rightfully so. I still think they will end up putting CMDlets back into PowerShell that may be used to create, manage, and monitor containers, but I guess we'll have to wait and see. But there is an established following of people making heavy use of the Docker platform already in order to develop it into containers, and Microsoft has made the decision with Windows Server 2016 to incorporate compatibility with Docker engine right into the operating system. In the end, you may need and probably will end up using a combination of PowerShell commands and the Docker tools. But if you are interested in looking closely into using application containers on your Windows server, make sure to install Docker and take a look at the extended capabilities provided here. Developers have the ability to use Docker to create an environment on their local workstation that mirrors a live server environment so that they can develop applications within containers and be assured that they will actually run once those applications are moved to the server. Docker is a platform that provides pack, ship, and run capabilities for your developers. Once finished with development, the container package can be handed over to the system administrator, who spins up the containers that will be running the application and deploys it accordingly. The developer doesn't know or care about the container infrastructure, and the admin doesn't know or care about the development process or capability with his servers. As I mentioned earlier, tools such as the containers and Docker are part of the cloud vision. While the use of containers for most companies is going to start on site by using their own servers and infrastructure for the hosting of containers, this is a technology that is already capable of extending to the cloud because the containers themselves are so standardized and fluid, making them easy to expand and move around. Sliding these containers into a cloud environment will be entirely possible. Docking on Windows Server 2016. The real reason we are talking about Docker here is because it is a tool that has never been usable on a Microsoft operating system before. But all of this changes with Windows Server 2016. You can now install Docker right onto your Server 2016 container host server and use it to create and interact with your containers running on that server. As we have already seen in the examples earlier, in fact, some folks may find that the Docker tools are comprehensive enough that you really don't need to utilize PowerShell in order to build new containers and could work exclusively from the Docker world. We have already run some commands to bring base images down onto our Server 2016 container server, but we didn't spin up a few containers from one of those images. Let's discuss the use of Docker commands to do just that. First, we can take a look at all of the container-based images available to us with a command called Docker images. And we can create a new container named cont6 by using the following Docker command: Docker run name cont6 it nano server cmd. One important note to keep in mind as we start to blur the lines between Windows and Linux: the Docker daemon that runs in Windows Server 2016 isn't going to be able to run Linux containers. This is by design, as there isn't virtualization trickery happening here. Docker on Windows Server 2016 is reusing the host operating system kernel, just like what Docker does in the Linux world. This means that the operating system between your container host server and the containers themselves need to match. You cannot run Windows containers on a Linux server. Why would you be able to run Linux containers on top of a Windows server? Docker Hub. When you work with containers, you are building container images that are usable on any server instance running the same host operating system. That is the essence of what containers enable you to do. When you spin up new instances of containers, you are just pulling new copies of the exact same image, which is all inclusive. This kind of standardized imaging mentality lends well to a shared community of images, a repository, so to speak, of images that people have built, which might benefit others. Docker is open source. After all, does such a sharing resource exist that you can visit in order to grab container image files for testing, or even upload your own images that you have created and share them with the world? Absolutely. And as part of the exercises in this chapter, you have already started using it. When we pulled down the base images from Microsoft, it is called Docker Hub and is available at http://hub.docker.com. Visit the site and create a login, and you will immediately have access to thousands of container base images that are common, that has the community has created and uploaded. This can be a quick way to get a lab up and running with containers, and many of these container images could even be used for production systems running the applications that the folks here have pre-installed for you inside these container images, or you can use Docker Hub to upload and store your own container images. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.